So in this session, I'm going to be talking about how to find and fight blocking issues. My name's Brent Ozar. I'm a Microsoft Certified Master, which just means I've made a whole lot of really expensive mistakes with other people's servers, and now I get to teach you how to avoid some of those same mistakes. All I do is performance tuning. All day long, people call me in and say, you have like 3 days to fix a bunch of performance emergencies. So I'm very used to troubleshooting blocking problems live in production. I've done all kinds of free scripts out there to help folks, SP Blitz first, all kinds of things to make your job easier. Everything that I'm going to talk about today, all the scripts that I'm going to use, how to get the Stack Overflow database, is all up at brentozar.com/go/lock. I actually have a 3-hour version of this session because there's so much that I want to go into. So there's way more resources up there at /go/lock. I'll show that URL down at the end later as well. There's two things that you can run into with locks. If someone takes out a lock and they're all alone on the development server, it doesn't matter. You can take out locks all day, every day, and it doesn't slow anyone down. You run into problems where you want a lock that someone else already has. Concurrency is the issue that we run into that causes both blocking waits and deadlocks. Locking is one of those issues that never shows up in the development server because we're working by ourselves. But when we go deploy an app out into production, that's when you run into lock waits and concurrency issues. And there's two different ways that you can see blocking pop up in SQL Server. In the first way, if Larry just takes out a lock, it doesn't matter. But if Larry takes out a lock and Sarah wants it, if Sarah wants a lock that Larry already has, SQL Server has no concept of a lock timeout by default. SQL Server will let Sarah wait forever. The symptom of this is that Sarah gets really pissed off. Sarah's queries are just taking forever in order to run. This is when your phone rings. Thank you, you are an angel. This is when your phone rings where people are really frustrated that the application feels like it's taking forever to open screens. This is where performance issues usually start. The second way that you can run into it, the bottom set down here, deadlocks. If Larry takes out some locks, and then Sarah takes out some locks, and then they both want locks that each other have, it's like what we call a Mexican standoff, where multiple people are pointing guns at each other, and no one is able to make any progress forward. Every 5 seconds, SQL Server wakes up and checks for this. Every 5 seconds, SQL Server looks for Mexican standoffs, and whenever it sees them, it simply draws its own gun and puts a bullet in whatever query would be the easiest to roll back. Now, this is going to kind of sound backwards, but users almost never complain about deadlocks in a mature application. Usually they complain really early on when we first find deadlock issues, but once the application is big and at scale, you don't get people calling in about deadlock problems. You get people calling in about blocking problems. Usually when we see deadlocks, it's application queries, like service queries that are running all the time in the background. And they run into a deadlock, they simply fail, and then the application tries it again later. I'm going to sound kind of weird, but I don't really care about deadlocks. It's the developer's job to build in a retry in their application. This is the point where developers start throwing things at me and saying that I suck. I used to be a developer, and I know how hard that is. But the thing is, both of these have exactly the same solution. In order to keep this to just 1 hour, I'm not going to demo deadlocks. I'm only going to demo locking, but the solutions are exactly the same, even though the symptoms may not look the same when I'm working on it. I'm going to give you 2 ways to fix this. One is to get the right number of indexes, and I'm going to show you what the right number of indexes is. Second is to use the right isolation level for your application, and I'll talk about what that is as well. For the first one, for right-sizing indexes, I'm going to use the Stack Overflow database. StackOverflow.com, how many of us have gotten our job saved because someone else did the work for us on StackOverflow.com? Yeah, Stack Overflow is where you post questions and someone else does all the hard work, and then you copy-paste the code and put it directly into your application. I know, because when I'm troubleshooting people's code, one of the first things I do is I copy-paste it into Google, and I see the answer that you stole it from. I can see where you took your code at. And I'm not just talking about developers. DBAs do the same thing. I love the Stack Overflow database. It's totally open source. It's Creative Commons. Anyone can download it and use it for demos. And it's so much better than AdventureWorks. I never want to see another bicycle store demo again as long as I live. That database sucks. The company went out of business. If you look at the sales history tables, the way a real user would look at it, you'll see that AdventureWorks is selling bicycles for 99 cents. I see why they went out of business. Now, Stack Overflow's demo database is really simple. It's only got a handful of tables in it. It's really easy to understand. And in here, I'm only going to use one table. I'm going to use the users table, which has exactly what you think it has. Every user who's ever logged in, left a comment, left a question at Stack Overflow. The primary key on the users table is an ID. It's an identity, an integer, starts at 1 and goes up to a bajillion. And in SQL Server, we like to say that the clustered index has all of the fields on it. It's a bunch of 8K pages that I like to visualize as actual pieces of paper. When I teach smaller groups, I actually print out the clustered index of the users table, only the first few pages, and here's what it looks like. Down the left-hand side, you see the ID field, starts at 1 and goes up to however many. Then we have reputation, creation date, display name, last access date, where the person lives, their location, their age, and their About Me field. About Me field is where you start to learn that I stretch the truth a little bit. I'll tell you that the clustered index has everything on it, and that's kind of true. But at Stack Overflow, the About Me is an nvarchar max. We let you put whatever you want inside the About Me field. That data actually gets stored on other 8K pages, depending on how large it is. That off-row data can be really expensive when SQL Server has to go look up those big nvarchar max, varchar max. You'll hear different presenters say varchar and nvarchar differently. Some of them say varchar. I like to say varchar because I'm a caring guy. I care about my data. Why would you say varchar? You want to burn your data? I've worked with data like that, but I don't really want to think that way. These 8K pages, these literal pieces of paper, are going to be the only copy of the users table that I have to begin with. I want you to visualize having a stack of these in front of you that you're going to be working with. I'm going to run queries on the database, but I want you to understand that when I'm searching for a user by ID, I can seek directly into that user. But what if I ask for, say, users who'd access the system on a certain date? What if I was saying where last access date equals a particular number? And you'll also see that this thing is kind of janky today. Last access date equals a certain number. You're going to have to rip through all of these pages in order to find the people who access the system on a certain date. SQL Server has no magic tricks. If you ask for something and there's no index on it, it rolls up its sleeves and scans the whole entire table. And I'll show you what I mean by that. What I'm going to do is I'm going to start by running a few queries. Now, what I'm showing you, I'm doing in SQL Server Management Studio 2016. Everything I'm going to talk about is exactly the same all the way back to 2000. Nothing is new in here inside this. Over on the left-hand side here, you'll notice I also have a stored procedure to drop my indexes, because why wouldn't you? That's just fun. So over on the left-hand side, I'm going to start by saying, tell me how many people access the system on my birthday. Wasn't born in 2013, obviously. I look good, but not quite that good. So there were 1,330 people who accessed the system on my birthday. In order to run that query, how did SQL Server execute it? Well, when I only have the clustered index of the table, SQL Server only has one option. It has to scan the entire clustered index. We'll make more changes to the table later, but that's all we're going to start with. We're going to assume that, how many of us in here are developers? How many of us in here are DBAs? So it's clearly biased towards developers. So what I'm going to say is, let's pretend you have a really crappy DBA who doesn't do anything in terms of index tuning. For those of you who are DBAs, you can say pretend you have really crappy developers who never build the indexes for you. If I only have this copy of the table, then when I want to do something like this, what is my execution plan going to look like? Think about as a human being with a whole stack of users' papers in front of you. How are you going to find the people who access the system on my birthday and update them? There's no rocket science here. You're going to have to read the entire table. And as you read that table, you're going to be taking locks on specific rows as you step through them. Let's execute that query. Now, you'll notice I was a bad developer. I started a transaction and I did not commit it. My locks are still being held open. I am not suggesting this is how you build apps. I'm just trying to make time happen really slowly here. In reality, this would be something like a stored procedure where you have a begin tran, some updates, and then some other code. I'm just going to slow down time here for a second. See how many rows were affected, and then look at SQL Server's execution plan. How did it go about doing this work? Well, we like to say that execution plans suck. They suck the data from right to left across the execution plan. So we start by reading over at the far right. SQL Server's first operation here was to scan the entire clustered index. Because that's all I have. This is my only copy of the table. And as it finds the rows that it's going to update, it goes through and updates them. Now, I've only updated 1,330 rows. Over on the other side over here, I have another query, and I'm going to execute that. What I'm saying is, go show me everything you know about user 26837. That's me at Stack Overflow. My last access date does not match that filter. I have a totally different last access date. But this query will wait and wait and wait forever. There is no concept by default of a lock timeout in SQL Server. SQL Server will just wait patiently until that update finishes. Why isn't this query moving faster? Well, in order to see it, let's use a really cool utility from Atom Mechanic. Adam Mechanic is an MVP out of the Boston area, and he wrote this stored procedure called SP Who is Active, and it shows me what queries are active on my SQL Server right now, ordered from oldest to newest. The top line is my update statement. You'll notice that it says something kind of weird in here. It says this set statistics command. This is a leftover of me asking for my execution plan. The bottom one is my select. My select is waiting. My select has been waiting for 52 seconds in order to get a lock. LCK waits. My query wants a lock before it can get started. Who has that lock? Well, if I scroll across a little further, blocking session ID tells me the person who's blocking me. I want more details than that. And in order to see more details, I'm going to run SP who is active with get locks equals 1. The more parameters that you pass in to who is active, the longer it takes. But if I use that get locks parameter, I get this new column over here for locks. And when I click on it, it gives me a little XML property bag here of all the locks that I have. That update query has a lock on the users table. He has gotten an exclusive lock across the entire object. That's what that X means. And on the key, he even knows we only locked 1,330 rows. If I look at the keys that I've locked, I've only locked 1,330 rows, but still SQL Server said, screw it, let's just lock the entire table. So no selects anywhere on that table can make progress until my update finishes. That sucks. We need a better way to go about doing concurrent reads and writes. When they talk about locking in SQL Server, this is what they mean by readers can block writers and writers can block readers by default. So how could I fix this? If I go back over to this select statement that's running, how could I make this get past that lock? With no lock. So let's stop it. And let's try it again with no lock. Execute, and the data finishes immediately. It says Brent's last access date does not match that birthday filter. My birthday is November the 10th. And I don't match that, but I'm still getting blocked by that update statement. Is no lock a good idea? Well, there's a couple of problems with that. You can see data that was never committed. You can see rows twice. You can skip rows entirely. And your query can fail with an error. Could not continue scan with no lock due to data movement. I'm going to say something that you wouldn't think a database professional would say, but if you're okay with seeing data twice, seeing data not at all, having your query fail, and seeing data that was never committed, then no lock is fine. Not all your data needs to be perfect. If you're Instagram, if you're Facebook, if you're showing cat pictures, does it really matter if you show a cat twice or you skip a cat? Not at all. No lock is cool for stuff like that. Or data warehouses, any kind of financial reports. Now, I know what you're thinking. Brent, that seems crazy. But here's the deal with financial reports. Your executives are looking at numbers and making bad decisions. It doesn't matter what numbers you give them. They're going to make the wrong decisions anyway. You could put random numbers up there and you'd probably be fine. It would make their queries finish faster. No, obviously not. If healthcare is involved, financial reports, we can't just say no lock everything and call it a day. It's not going to work. I'm going to need something else. Now, I'm okay with no lock in some situations. It's not so bad, but let's pop back out. Stop. Oh, I wonder if it went down further. Oh, yeah, it did. So back over here on my begin tran, I'm going to do a rollback just so that that query never happened. And then I'm going to go do something here that might seem odd. I'm going to create an index. The index that I'm creating here is on last access date. That's the field that I'm using for my filter to update. I'm saying, give me another copy of this table sorted by last access date and ID. Let me show you what that looks like. It's also stored on 8K pages, just like our clustered index was. But on these 8K pages, the only thing that's on them is last access date and ID, and that's it. So when I create this index and I go do that update statement, now when I say update the people who use the system on a certain date, SQL Server can use this index in order to build the update query. Watch what happens differently. If I go execute my update query again, I'm going to do a begin tran and my update. It still finishes instantly. It always did. It never really needed an index, but look at what it's doing now. Now it's saying, go do an index seek first. Use that index that you just created in order to find those 1,330 rows that you're going to update. Now, even though I've done a begin tran, I've done this begin tran over here, I'm going to switch over to the right-hand side, and I'm going to execute my select again, but I'm going to take out the no lock and execute. Bam. It works. Why does that work? It's not like this query is going to use the index. Even though I have a separate copy of the table, that when I look at that query's execution plan, it doesn't use the index. It's still using the clustered index of the table, the same thing we were locking earlier. But here's the thing. When I go back and look at SP who is active with get locks equals 1, let's go see what locks our update has now. And now they're different. Now, instead of having an X exclusive lock on the clustered index, I only have an intent exclusive lock. This query is saying, heads up, I'm going to update a few rows. How many rows? 1,330. I have an exclusive lock on 1,330 rows, but I don't need to lock the whole table yet. I might later, but I don't now. Indexes make updates, deletes faster and let you run select queries against the table at the same time. It starts to introduce a little dance here back and forth between these indexes. Indexes aren't just for making select queries go faster. They're also for helping concurrency. Especially if I start to do stuff like this. What if I say over on my select count star from DBO users? Go show me how many users access the system on any date. In order to accomplish this query, I have to read the whole table, right? No, I have to read a copy of the table, but it doesn't matter which copy. And SQL Server's smart enough to scan the narrowest index available in order to accomplish this task. Even though I'm not doing a query against last access date, SQL Server still uses that index because it's the most lightweight copy of the table that we have. What if I want to find the people who access the system on my birthday? Remember, these guys are locked over here. These 1,330 rows where last access date is my birthday. Over here in the select query, Can we count them? Yes. Their rows on the clustered index are locked, but not on the non-clustered. So if I want anything like last access date and ID, which are both fields that are available on my non-clustered index, that query is able to still finish. But if I try to get fancy, and if I try to add any other field, like if I say, show me their display name is not on the non-clustered index. So this query is blocked. This is such an interesting dance in SQL Server. I want to figure out how many indexes I can add in order to make my select queries go faster. But the more indexes that I add, I will make my deletes, updates, and inserts go slower, because SQL Server may have to update those indexes every time values in them change. There's no good advice out there for how many indexes your table should have. So as a general rule, I tell people to think about having 5 or less indexes per table and 5 or less fields on those indexes. When you have more than 5 indexes, you can, at Stack Overflow, for example, for a while, we had 30 to 40 indexes on some of our biggest tables, but it's because we could cache the entire database in RAM and we had all solid state underneath us. You can break a lot of rules when you shovel .com money into your hardware. For the rest of us, 5 or less indexes with 5 or less fields per index is a good starting compromise. You might ask, Brent, where do those numbers come from? Well, it's because I have 5 fingers on this hand. I have 5 fingers on this other hand. If my mother was a mutant, we might be talking about Brent's rule of 6 and 6 instead of 5 and 5. So so far so good. I'm able to do some queries. I'm able to select what I want off of Brent's individual row, and Brent's row works fine, even though I have, over on this other side, locked 1,330 rows of that table. Let's go find some more people who access the system on my birthday, but instead of 2013, let's go look at 2014. I still haven't committed my transaction. My locks are still open. I'm just now locking more rows than I had locked before. You can see how many rows I've locked there, another 3,200 rows. Over on the right-hand side, if I go to do my select still works. I can still queries Brent's data. I can still get everything I want from users as long as I'm not trying to touch any of those locked fields. If I say select count star from users, I can still scan my entire non-clustered index and get a count out of there. If I go back and look at SP who is active and I run it with get locks equals 1, now I can see what kinds of locks he has. I'm going to click on the locks column, and it shows me that I still only have an intent exclusive lock on that object, and I'm really only locking 4,500, 4,500 keys out of the, listen, I'll get good at keyboards one of these days. I'm locking 4,564 keys. I'm not locking the whole table. I'm only locking 4,500 rows. Let's push our luck a little bit further. So we gave people 100 more reputation points in 2014. Let's go for 2015 too. Let's go update the people who accessed the system on my birthday in 2015. Now we've locked more rows. And now let's go run Brent's query again. And if I go say, select star from users where ID equals 26,837, something has changed. I'm not able to query Brent's row, even though Brent's row, why am I calling myself a different person? I'm not able to query my own row, even though my own row isn't one of the ones being changed. The reason why, if I go look at SP who is active now, and I see what locks are being held, notice that now my select query is getting blocked. And what is he getting blocked by? Here's the locks that the update has, and it looks different now. SQL Server stopped counting however many rows were locked before. Now SQL Server says, you've locked so many rows, screw it. I'm just going to escalate your lock to the entire table. You don't have control over this. SQL Server manages locks internally. That table has 5 million rows in it, 5 million rows. And yet, even though I've only locked about 10,000 rows, SQL Server has still escalated my lock all the way up to a table level lock. It has nothing to do with the size of the table. It has nothing to do with the horsepower on your server. Whenever about 5,000 locks are being held on an object, that's where SQL Server starts promoting some of those locks up to table locks. Look, you keep locking more and more rows, I'm just going to say screw it and have you go lock the entire table instead. This is another one of those interesting things that happens to us in development. We build an app, and at first, everything works fine. Performance is cool, because we're only updating, say, 3,000, 4,000 rows in our batches. But then we build bigger jobs. We run queries that affect more and more rows. Our batch jobs affect more and more rows. And all of a sudden, we start tripping over lock escalation and jumping into table locks when we didn't have to deal with that before. Indexes won't save me here, even though SQL Server knows exactly how many rows are going to get locked. It still says, screw it, I'm going all the way up to a table lock. Questions on this so far? Yes? Is up in the finger in the, it's only 5,000. That sucks even worse. But yeah, it's in terms of putting the finger up in the air, 5,000 rows is just a ballpark. Microsoft says this is one of those things where they say, we control this, you don't worry your pretty little mind about it. We'll take care of lock escalation for you. But when you run experiments, you can see it hits right at about 5,000 rows. Yes?
What's the point of not including, but taking ID to the index?
Oh, that's a great question. Why, when I did the index, did I put the ID inside that index? Here's the create index statement. I do that because most of the time when I'm presenting, it's in America and the audience is not nearly as bright. Over here in Europe, you all understand that the ID is always included if it's the clustering key in every index. I do this just to hammer home to those dumb Americans that this really has the ID inside of it. Sometimes, that's why I'm so much more popular in Europe, right? So the sad thing is I make the same joke about you guys when I'm presenting in America. So those crazy Europeans. The other thing that's interesting, sometimes you'll see in SQL Server Management Studio, you'll see the missing index recommendation, and it'll say you should include the ID. It does that when your query has the ID in the select statement because SQL Server's paranoid that someone could change the clustering key behind you. If you need the ID out in your queries, they'll tell you you should create it inside the index. I live in a world where no one changes their clustering indexes on a regular basis, so I don't care whether people put the ID in or not. Is it an actual answer to the question? Is there a reason? Yeah, is there a reason why I put it in there? Just to drive home to people? You totally don't need it. You totally don't have to put it in there. You love Europeans? Really smart? Yes. Next question so far. More questions so far.
You did the update with row locking.
Oh, you're one of those bad people. So if you do the update with row lock hint, will it hold row locks? Yes, but there's a memory impact to that. SQL Server uses memory in order to track locks, and the more of it you use, the less is available to cache these 8K data pages. So I got to be careful about that. I do like people who use, this is going to sound weird, I do like people who use tab lock hints in their queries. If you know that your ETL job is going to burn up a whole bunch of rows and you just want to get in and get out fairly quickly, that's often faster using tab lock hints. What about update lock? Usually that's used in select statements where you're going to go select something and say, I reserve the right to update this later. I'll show you a better way to do that here in a second. What about disabling lock escalation? God bless you. Usually it's the Americans that want to break all the rules. The Americans are like, hold my beer, watch this. So you can disable lock escalation, but then you run into the problem of more memory getting burned up by managing all these row locks. I don't want that to happen. I want SQL Server.
Did you see that situation that the memory was burned up?
Oh, you would not believe the things I've seen. It takes so much therapy. Yes, have I seen the situations where people disable lock escalation and then they do 5 million row ETL jobs and they wonder why their SQL Server is screaming in the corner, crying in shame?
Do you have any proportion of amount of data for logs?
Do I have any proportion? I really like what Microsoft does, that if you go over 5,000 rows, let's just lock the table and see what happens. Unless, if you're doing nightly warehouse jobs, if you do big data loads, lock the whole table. If you want to learn more about this too, Michael J. Swart is a blogger. He's not American, he's Canadian, so you can trust what he does. Michael J. Swart, batching, has a great blog post on what you should do when you're scripting batches. Now, I'm going to come back to the title just so that you can take pictures or whatever, but here's the important part. He goes through scientific experiments to try different batch sizes with his workload to find where the sweet spot is. Is it at 1,000 rows, 3,000 rows, 10,000 rows? Where is it that his jobs perform fastest? You can see all of his work, including the script that he uses. Michael J. Swart, take care when scripting batches. And it really is different for every workload. 5,000 isn't a great answer for stuff like data warehouses. More questions so far? Yes. You just want to hear me bash Americans, right? Yeah.
What happens when you disable the row lock on the page?
What happens if you disable row lock? So that would be pretty bad if you have an OLTP activity where people are doing small insert updates and deletes across individual rows. But if you had some reason where you wanted to micromanage locks that way, there's a really interesting session at SQL Bits. I'm going to search SQL Bits Thomas Kaiser. So Thomas Kaiser, he's European, again, so you can trust what he says. If you search for, and this one's a little wide, so I got to have it on both sides. Over on the right-hand side, it says presented by Thomas Kaiser at SQL Bits. Thomas had a scenario where he wanted to, were you in the pre-con yesterday? Yeah. So for the rest of the folks, this guy wanted to drive 100% CPU across like 64 or 80 cores. He could not have any lock weights, any I/O weights. He had super blazing fast storage, tons of RAM. He worked for Microsoft at the time, was doing performance tuning for a customer. So if you want to see what it's like to really get 100% CPU across, say, 64 cores, this is a spectacular session to watch. The video's on there. I would just say that it's kind of like a car crash. It's fun to watch Russian dash cam videos on YouTube. It's just that you probably don't want to be involved in this. Don't use those techniques unless you're trying to achieve those results. I don't know a lot of people who want 100% CPU use. Most people seem to be allergic to that. All right, so next, to come bring in this back home, let's go back over here. Jump down. Here we go. So the takeaway out of that first part there, and it makes it sound like I'm going to have 10 parts in this session. The takeaways out of the first part there, indexes aren't just for selects, they're also for helping deletes, updates, and inserts go faster. I'm going to aim generally for around 5 indexes per table, around 5 fields or less per index. This is not a gospel rule. And before you go tuning any specifics, whether they're queries or indexes, go use the totally free open source SP Blitz index. This is 100% open source, MIT licensed. You can use it with clients. You can make changes if you like. You don't have to report your changes back into anyone else. And we wrote that because we have a really frustrating time doing index tuning too. So it tells you when you have too many indexes, when you have blocking weights that are happening, when you have desperately needed indexes. There's just one tip I'm going to give you, because I know, just like Americans, you're not going to read the documentation, because no one ever reads the documentation. If you look at create index hints that come out of SQL Server Management Studio and execution plans and SP Blitz index, it'll say create index and it'll give you a list of fields. Those are not in order. It looks like they are, but they are just a comma delimited list of fields you should consider ordering. The recommendations are often in the wrong order, and you'll want to mix them around in different orders to figure out which one's the fastest for you. Flat out says that in books online when it talks about the missing index DMVs, but if you're anything like me, you don't read the documentation until you've been burned a few times. So the second part of this is isolation levels. By default, SQL Server uses pessimistic locking, which means readers can block writers and writers can block readers, which is what we just saw. Yes, you can use the no lock hint, which just does dirty reads, but that's not usually good enough for financial applications, healthcare, and people like Europeans who want accurate reports as opposed to us American. We have alternative facts inside our database systems. So let's say that our data consists of 3 marbles. We have a white marble and 2 black marbles. I'm going to call this marble ID number 1, marble ID number 2, and marble ID number 3. If I start an update statement and I say, go change the marble number 2 and change his color from black to white, what SQL Server is going to do is go take out a lock on marble ID number 2. This is just a row lock. It's only taking out a row lock on marble ID number 2. But if I now run a select query, and if I now say, go show me the number of black marbles, that select is going to get blocked. The select can't read marble ID number 2 until the update finishes. He's blocked. It takes some time, but after the update finishes, then the select finishes, and he sees that the marble black count is 1. Now I need to be specific. That select answer is true for the moment in time that the query finished. It's not true as of the moment in time when the query started. If I jump back just a little bit earlier, that select, when he first got started, there were 2 black marbles. The update hadn't committed yet, but because of the default isolation level in SQL Server, you see answers that are correct as of when your query finishes. But there's another option. Optimistic locking. This is not set up by default. There's a couple of different ways you can turn this on. We'll talk about how you go about turning it on. With optimistic locking, I still have 2 black marbles. I still issue my update statement. And I still take out a lock. That part doesn't change. But when my select comes in, the select says, or before the select comes in, SQL Server Engine automatically, whenever you do inserts, updates, or deletes, the SQL Server Engine copies the original version of your data into TempDB. I like to call TempDB SQL Server's public toilet. because there's so much dirty, nasty, disgusting things happening inside there. It's not just people creating temp tables, it's the SQL Server engine doing things like row versioning. So SQL Server, as soon as I turn on optimistic locking, starts writing copies of your data into the toilet. So that now when the select comes in, the select goes to look at this locked row and says, well, I can't read this. Someone's working on it right now, but I can go grab the original version out of the toilet. And this is where the analogy breaks down, because the copy of your data in the toilet is actually clean, whatever. So I'm going to go get my select data out of the toilet, and my select data finishes, but it's true as of when my query started. That update may end up committing at the same time, so I may see a select that shows 1 black marble, even though there were maybe 2 black marbles when I started this query, mixing things around a little bit. This isn't a showstopper of a problem. Most folks would much rather do this than be blocked forever waiting for that update to finish. So here's the differences between those two. With pessimistic locking by default, I saw a true version as of when my query finished. With optimistic locking, I saw a true version as of when my query started. Now, there's 2 ways that I can turn this on in SQL Server, and they're really confusing, and I've got much more details about this over on the blog. Both of these ways of turning it on start writing my data into the toilet as soon as they happen. But with the right-hand side, with snapshot isolation, the data's in the toilet there, but you have to ask for it if you want it. You have to say at the beginning of your transaction, set transaction isolation level snapshot. This lets whatever selects you want start getting their data out of the toilet. The one over on the left-hand side, this turns on everyone's isolation level to read committed snapshot by default. So everyone starts getting their data out of the toilet right away, whether they asked for it or not. Questions about those two?
Why do you say can be used for modifications now under review?
Hit the blog for that, because we go into details on examples for that. I hate this. I want to go into like 2 hours of, and another thing that's really cool. So, this is a common feature now. The people who are using this, Azure SQLDB uses it, and you can't turn it off. It's on by default, has always been on by default. It just simply works. I'm a strong believer that anyone who starts a brand new application in the year 2017 should be using this, because it just makes your blocking problems mostly go away. Not perfect, but most of the time. Always on availability groups. When you read from a secondary, this is the exact mechanism that SQL Server is using to update the data underneath it while you query it. And although the funny part is, it doesn't look like that feature is turned on to you. The DMVs show that it's not turned on, but SQL Server's hidden using it under the covers. Oracle and Postgres use this. They call it multi-version concurrency control, or MVCC. This is one of the reasons they were smoking us on benchmarks for the longest time, because a lot of benchmarks out there, like the TPCC benchmarks, will tell you you can only use settings that are turned on this way by default. You're not allowed to change certain kinds of database level settings. Oracle saw that, and they wanted to win benchmarks, so what did they do? They just turned on optimistic locking by default, and they went, screw you, SQL Server, we win. I like how Microsoft doesn't change the defaults on you, because this can break your code. You can run into race conditions, and we've got an example of one over on the blog. If you use CDC or change tracking, Microsoft actually recommends that you should turn this feature on by default, because with CDC and change tracking, SQL Server is constantly trying to read from exactly the same data that you're changing all of the time. RCSI, the default of switching everyone's isolation level over to read committed snapshot has a horrible drawback around race conditions that can surprise people. I'll refer you to the blog on that one. But if you're dealing with anybody's third-party code, if you have an app that was designed to work for Oracle and Postgres and SQL Server, then it already is completely fine with multi-version concurrency control because those other databases have it on by default already. If you built an application that works across both SQL Server and Oracle, you can safely turn on RCSI and not worry about it at all. But if you're worried about any changes to your application, you can throw the switch on snapshot isolation and just let your report query start to hammer it. How many of our users tell us that they want to run reports straight out of production? They don't want to build a data warehouse. They just want to query everything live. They also can't wait a single second in order to get their reporting data. I need to see it up to the exact moment in time. And they write the world's ugliest queries. It's some moron with Excel. He's like, I have Power BI now. Nothing can stop me. I should be hooked up to production. And you're tired of his queries blocking people who are trying to put sales into the database? Snapshot isolation is perfect because then you can have just that guy turn on snapshot isolation in his reports and he magically stops blocking other people and other people magically stop blocking him. So what we talked about through here, first off, you want to have enough indexes that it makes your queries go fast, but not so many indexes that it makes your query go slow. This is the magic roll of 5 and 5. You want to use the right isolation level for your app's needs. If you're building a new app in the year 2017, check out RCSI. It's freaking amazing and makes a lot of blocking problems go away. And because this is something that comes up all the time, we have easily 50 different blog posts on there on brentozar.com/go/lock, where we show you how to analyze deadlocks, do weight stats analysis, do index analysis to find exactly the right mix of indexes for you. Now, open questions. What questions do you guys have from out of what we covered? Who wants to go first? Yes.
Do you know any drawbacks?
No. No. Do I know any drawbacks? So there's one edge case drawback around a race condition. And because we have a few minutes, I'm going to show it to you. And because I like Uwe, who asked the question, I probably didn't pronounce his name right, but that's, you know. It was correct? No, get out of here. I should say it a few times now, make sure I get it right.
Call me Yui, it's better to pronounce to you.
It's better Yui? Oh, that's a very American kind of thing. When I hear Yui, I immediately think Huey Lewis in the News. Yeah. Or turn a Yui. They always think of that too. So let's say we have a really bad stored procedure. I'm not saying this design is right. This design is awful. But let's say we have a stored procedure. And the first thing that this stored procedure does is start a transaction. It goes and finds the person in our company who has the least tickets assigned to them and is alphabetically first, and it puts that in a variable. Then it turns around and updates that help desk person and the ticket to assign it to them. Under the default, with pessimistic locking, this stored procedure fires off. It looks at who's the first help desk person available, and it sees that Brent doesn't have any tickets available or doesn't have any tickets assigned yet. So it does this select, and the select works, finds Brent, and then starts updating Brent to give him a ticket. When another server kicks off and does this same exact process, the select is blocked. Because remember, in pessimistic locking, readers can block writers and writers can block readers. So the select query doesn't even get a chance to start. It patiently waits until the update is finished. And after the update is finished, it goes and finds the next person who's alphabetically available, Tara in this case. Things are a little bit different when I start with RCSI. The stored procedure still starts, the select still runs, and the update starts. The update takes out a lock, just as it always did. But remember, an original copy of my row in the help desk table is now over in TempDB. When the second stored procedure starts, the second procedure starts by doing a select. He can select. So he can select my row out of TempDB and see that I don't have any tickets assigned. And then his update starts. So the end result of this is that now Brent has 2 tickets and Tara does not have any. You could argue that no code should be written this way. No code should first do a select and dump data into a variable and then do updates based on that variable. You should also argue that I should be a millionaire and have a Ferrari like Uwe, but unfortunately, I do not. So in this world, RCSI is a little bit risky. That's the big risk on RCSI. The other one people seem to worry about all the time is TempDB. I said suddenly now your inserts, updates, and deletes are going to start writing data into TempDB. This has 2 bad impacts. One, it starts putting TempDB under more load. If you have a crappy, underpowered server, VMs are notorious for this because TempDB lives out on the SAN. If you have an underpowered server, you can run into problems then with TempDB slowing down your inserts, updates, and deletes. The second concern is capacity. What happens if Dan the DBA, since there's more developers in here, Dan the DBA goes to his workstation, does an update, locks his workstation, forgets to commit, and goes out to start drinking on Friday night? If he leaves his transaction open, now I got a couple of different problems. Sure, he left a lock behind, but TempDB is growing like crazy now. All these inserts, updates, and deletes are getting shoveled into TempDB. So in both of those cases, I don't see them as a big deal often these days because solid state drives for TempDB have gotten really cheap. You can get a 1 terabyte solid state drive for like $250 US. But it's just something I have to warn people about because when you're in the environment with a crappy TempDB, that can be a surprise. Monitoring tools are wonderful for this. Everybody's monitoring tools, no matter who you buy, will warn you about TempDB filling up and responding slower because these features have been around for more than a decade.
When we are seeing the snapshot and relation of select statement, will it be still considering using index versus TempDB, or it will always just follow TempDB, and which is probably less performant?
No, that's a great question. This is going to be kind of tricky. Indexes go into TempDB too. So it will use indexes over in TempDB. Your queries will still go fast. Yeah. Next question. No, you guys are dumbfounded. How many of you now want to go back and fix indexes or change your isolation levels? No? Not, yeah, a few of you. Okay, cool. Well, thanks for hanging out with me this morning. Have fun at SQL Day, and I will see you guys later around the conference. Adios.